So now in this video, we're going to use an NPN bipolar junction transistor. I'm using the 2N3904 here. We got emitter base collector, emitter base collector. We are going to set a current. It's going to be a current source, about 10 milliamps of current. We can change the supply voltage and add an LED as long as we have enough voltage to power everything. And we're going to get basically the same amount of current. The reason why is because we're going to set a voltage at the base using a Zener diode, which we have right there. Reverse bias builds up its Zener voltage when it has some current flowing through it. 10,000 ohm resistor, we don't need much current. And so we're going to build up 5.6 volts at the base of the NPN bipolar junction transistor. You lose about 0.6 volts, but that voltage gets transferred over to the emitter, and we have a resistor right here. So 5 volts divided by 500 ohms, this is actually 510, so it'll be slightly smaller, but 5 volts divided by 500 ohms is 0.01 amps, or 10 milliamps of current. That's going to flow through. So we could do a short circuit. Right now it's not connected. I could short circuit that. Or we could add an LED, even 2 LEDs or more, as long as we have enough voltage. We're going to need 2 extra volts for every LED. And so yeah, here I put, we're probably safe with 13 volts with a short circuit. And over here with 1 LED, we could go up to 15 volts because this is going to drop a couple of volts. And the rest of this absorbs, a lot of power. And so for every LED, we could go up like a couple more volts. For like a couple more LEDs. There'd be an upper limit. I don't know exactly what it is. So yeah, for the current, we can just look at the power source, and there's a little bit of current flowing, but now this is almost all the current that's going through that wire, the transistor, and that resistor right there. So probably just a speck less than 10 milliamps of current, and I believe I put that up one spot. But yeah, now we got a red LED. And there you can see, it's still 9 milliamps of current. If I add another red LED, we may need to add some more voltage. Yeah, I think we need to add some more voltage. But again, it's trying to get 10 milliamps of current. And there you can see, we can go up to 15. Probably 17 is just fine right now because there's 2 of them. But yeah, there you can see, it's holding a pretty much 10 milliamps of current, even as we kept increasing things. Let's go to 13 as I said before, and because we didn't look at the short circuit with the 13 volts, we'll short it. There we go. We still got 9, probably just slightly less than 10 milliamps of current on there. So now if you absolutely want to measure current with the multimeter, it's not too hard. We are going to be in the milliamp range. If there's numbers, make sure you set it to a number higher than you need to. And I don't need to move the red probe for anything except for high current. So we don't have high current here, the amp range, and so just leave the red probe where it is. And we can take our measurement. So we got about 9.8 milliamps of current. I have the power supply set to 13 volts, and we will add an LED. This should be enough voltage to add 2 LEDs, but we'll add 1. Look at the current. So you got to complete the circuit through the meter right there, and pretty much spot on the exact same current, even though we changed the load really significantly. We didn't add like a big load, but we went from nothing at all to an LED, which is a big difference in the grand scheme of things. And there you can see, pretty much spot on exact same current, even though we changed the load a lot. And I can leave the LEDs there. I can just bypass one and bypass the other. Hopefully I don't short anything. Just going to the collector right there. And now we're going to measure voltage. I got rid of that jumper just to save time. Make sure you get the whenever you're done measuring current, get it off of measuring current as quick as possible. Voltage is a safe setting. You could blow a fuse if you accidentally leave the meter set to measure current and you try to measure a voltage. You got to make sure you limit the current. So yeah, we need to have to get our voltage measurements current flowing through the collector. Otherwise we could get wrong measurements. So this resistor goes to the negative supply. First we'll look at our base voltage. Should be, somewhere around 5.6 volts. There you can see, just a speck higher. We got the base to emitter drop. That is 5 volts right there. Now we can see how much voltage is across the transistor here. with the two LEDs, it's going to go up when we get rid of the two LEDs. But yeah, we got about 4 volts. So 4 volts and 10 milliamps would be the wattage. And so that should be a 40 milliwatts of power. Far less than the maximum. It's like 600 with the max, 600 milliamps. And now we'll measure the voltage. This is still 5 volts. That should hold pretty much exact spot on. And I didn't memorize what it said before. That is 0.5. Why is that 0.5? We got 1.3. This is not connected. Yep, you gotta have the current flowing through to get the measurements. There we go. We got 5.6, what we expect. So yeah, that's another reason why you practice measuring stuff. We got 5 there, 5.6 there. Let's see what we got across the transistor now that we don't have the LEDs. And of course, it's 4 volts higher because the two LEDs were dropping 4 volts. So now we got 10 milliamps of current, and we got 8 volts. So that's going to be 80 milliwatts of power. So that transistor is not going to get too hot. But again, that's at 13 volts. And we're at some point I estimated that that'll be about the maximum. So I think the meter will turn off on its own, but after a while it'll start beeping. But in case, best to just turn it off as soon as you're done. And of course, always make sure it's off of milliamps of current until you're going to actually measure milliamps, or amps if you're going to measure amps, and so on, microamps. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.